So finding angles and solving right triangles, 6.5. So you'll notice that 6.1 to 6.4, we never did find any angles. We found sides. We are going to find angles today and talk about what it means to solve a right triangle. So first off, recall what inverse operations are. So inverse, remember, read opposite. So the opposite of adding is subtracting, just like the opposite of subtracting is adding. So the inverse of multiplying will be dividing. The inverse of, for example, squaring something would be square rooting and vice versa. So for this example, we have 2x minus 5 equals 3. So solving for x is you, smiles, and you are having a party at your house, your parents' phone, and they're coming home, so everybody's got to go. So 3 wasn't invited, so we don't have to worry about them. They weren't even here. So we need to get rid of this 2 and this 5. Now, whoever's closest to you will help you clean up. They're obviously your best buddies, basically attached to you at the hip. So this 2 is going to stay. This 5 has to go first. Now, you leave the opposite way you came, right? You don't exit a house by entering it again. So 5 entered the house, is attached to you, entered the house by subtracting itself on. So subtract 5. So it needs to do the opposite or the inverse to exit the house. So it will add 5. Now, this 5 isn't just going to all of a sudden walk out the door and poof, disappear, right? Well, you can see them walking away. They appear outside of your house. So what you do to one side, you have to do to the other. That 5 just doesn't disappear. But it is now out of your house, which is exactly what you want. So 2x equals 3 plus 5, which is 8. Now, your best buddy has to leave too because they also were not allowed to be here. So they are multiplied on to you. So multiplied onto your side, onto you. So it's 2 times x. So to get rid of the multiplying, I need to do the inverse operation dividing. So divide by 2, reduce to 1. So 1x equals 8 divided by 2, which is 4. So one of the common mistakes I see for an example like this would be like trying to divide by x, but you don't want to leave your house, right? Like you have to stay, so everybody else has to go. So x equals 4, just really simple review of solving an equation. Now, inverse operations, why I'm reviewing that is here we have sine to the -1, cos to the -1, and tan to the -1. So these are going to be the inverse trigonometric ratios for sine, cos, and tan, respectively. So sine, cos, and tan. Now, sine of an angle is 0.2546. So just like when we were doing solving for x up there, we need to solve for our angle. We need to solve for a. And notice how we have a sine here. So it's not sine times a. I can't divide by a sine. That's not really a thing. This is sine of a. So I need to do the inverse operation. So the inverse operation of sine is sine to the -1. So when I sine to the -1 this, that gets rid of it. But what I do to one side, I need to do to the other. So a equals sine to the -1 of 0.2546. Now, how we put this into our calculator? So your calculator will be something like this. If you look above sine, cos, and tan, you see sine to the -1, cos to the -1, and tan to the -1. How we get to them is we need to use our second function button. So what we will do is our calculator steps will be, we have to hit our second function button. Then we will hit our sine button to get to that sine to the -1 above there. And then we will type in 0.2546 and we will press equals or enter. And that will give us our answer. So let us do that. So we have second function, sine, brings up my sine to the -1 of 0.2546 and enter. And we get 14.7498, so on and so forth. So A equals 14.749, and then I want this to the nearest degree. So nearest degree, here's where I'm drawing my line, take a peek over. I do have to round that 14 to a 15. So A equals 15, and don't forget your units. This is an angle, so degrees. Now cos of b equals 0.1598. So same thing. I need to get rid of cos to solve for my angle. So I will use cos to the negative 1. So I will cos to the negative 1 of this side and cos to the negative 1 of this side. So it gets rid of it. So my angle B will equal cos to the negative 1 of 0.1598 equals. So into our calculator, so second function, cos, making sure once again you're in degrees, always be in degrees, of 0.1598. And we get 80.8047. So on and so forth. Or to the nearest degree, gonna have to round that 0 up to a 1. So 81 degrees is what B equals. Last one, so tan C. So this looks a little bit different because this 5 over 13 doesn't look like a number, but remember I could just do 5 divided by 13, and if I do 5 divided by 13, I get this number, which looks like that. So I would suggest not figuring this out and just putting the whole thing into your calculator, because nobody wants to write a bunch of decimals out, and as soon as you start rounding and cutting it off, so let's say if I did 10 to the negative 1 of 0.3846, it might be a little bit off, so we don't want to do that. So we will do the whole thing. So tan to the negative 1, this to get rid of that, and what I do to one side, I have to do the whole other side. So I have my angle C equals tan to the negative 1 of 5 over 13. And then putting that exact thing into my calculator. So second function, tan of 5 divided by 13. And we get 21.0375. Or to the nearest degree, just 21.0 degrees. Or just 21 degrees. Oh, what am I doing? 21 degrees is the nearest degree. There. There. Okay. Next example, we are going to calculate the indicated angle. So, and we will round to one decimal place. So here I am looking for angle A. So remember, our first step is always to label our triangle according to that angle. So this is opposite angle A. Here, this is adjacent to angle A. This is the hypotenuse because it's across from the right triangle, or sorry, from the right angle. So labeling. Second step, we circle 3. So 2 things I know and 1 that I need to find. And that will let us know which equation we are going to use. So I know this opposite side, I know this adjacent side, and I know that I want to find this angle. Okay, so as soon as I circle an angle, if I remember what I have in my triangle toolkit, as soon as I circle an angle, I am looking at SOHCAHTOA. If I had circled all 3 sides, I would be looking at Pythagoras, but I circled an angle. So I need to use either sine, cos, or tan. And I'm just going to write it up here for quick reference. So SOHCAHTOA, sine, cos, cosine, and tangent. Now I circled adjacent and opposite, so I didn't circle hypotenuse, so that gets rid of sine and cos, so it's tan that I need, so opposite and adjacent. So third step, we write our equation. So tan of our angle A is going to be opposite over adjacent. And substituting in, so tan of A equals opposite, which is 5 centimeters over 3 centimeters. Why I'm writing that, our units, is because you have to make sure you have the same units because they need to reduce, right? So if I had meters, for example, and centimeters, I would have to change either my centimeters to meters or my meters to centimeters just to get them to the same units to be able to use my inverse function. Okay, so just make sure that you have the same units in each. Now I'm looking for this angle, so I will need to get rid of this tan, and I do that by doing the inverse function of tan. Okay, so it gets rid of that. And equals tan to the negative 1 of 5/3. And putting that into our calculator, we get our angle A is 59.0367, so on and so forth. So A equals, rounding to 1 decimal place, go, take a peek over the wall, 59.0 degrees, or just 59 degrees is fine. So after subbing in, we solve, and don't forget our units. Okay, next example. So here's our angle that we're trying to solve. So first step, label. So here, this is opposite our angle. Here's our hypotenuse. Here is our adjacent. Now, circling 3. So two things I know are this side, and I'm looking for this angle. So I have circled an opposite and hypotenuse, so that will be sine. So sine of my angle is going to be opposite divided by hypotenuse. So substituting in, sine of B is going to be opposite, which is 5, divided by hypotenuse, which is 9. Now solving for B, so I need to get rid of sine by using inverse sine, so sine to the negative 1. Okay, so it gets rid of that. So B will be sine to the negative 1 of 5/9. And then putting that right into our calculators, we end up getting 33.748, so on and so forth, or to the nearest 1 decimal place. So 33.7. And our units are degrees. When you are asked to solve a triangle, you need to find the values of all the sides and all the angles. So in this triangle below, we have this angle, and we have this angle actually because it's 90 degrees. We have this side, and I need to find this side, and that angle. So side A, side B, and angle B. Now, you're just going to have to choose which one you want to solve for first because you want to find all of them. You can't just go around circling more than 3 things. So let's solve for side A first. Now, our first step is always labeling. So here's the angle that we're given. So opposite. Here's my adjacent side because this is my hypotenuse. It's across from my 90 degrees. So circling 3 things. So 2 things I know, 1 thing that I don't. So I know my hypotenuse. I know this angle. And we're, for the first bit, solving for this side, side A. So solving for side A. I've circled a hypotenuse and an opposite and an angle. So as soon as I circle an angle, I know from my triangle toolkit that I will be using sine, cos, or tan. And since I circled opposite and hypotenuse, that is going to be sine. So ga, toa. So sine is opposite and hypotenuse. So sine of my angle is going to be opposite divided by hypotenuse. Substituting in, so sine of 56 equals my opposite, which I don't know, it's A, divided by my hypotenuse, which is 8.7. And writing this as a ratio because this is WAM10 and it's ratios all around. Okay, so A will be dividing by 1 because that's across from the thing we don't know, and multiplying these 2 together. So we will have A equals 8.7 times sine of 56 degrees divided by 1, which is the same thing, so I don't need to write divide by 1. And putting that directly into your calculator, you end up getting 7.212, so on and so forth. Or let's just round this to the nearest tenth. So I'll take a peek over. It stays as 7.2. And lastly, make sure we have our units. So it will be 7.2 centimeters. So that's A. Okay, now solving for B. So let's solve for side B next. When I am solving for side B, I could now use the Pythagorean theorem. I know this side is 7.2. I know this side. I could figure out this last side using Pythagoras. The only problem is if I made a mistake somewhere here, then this answer will also be wrong. So it's usually safest to stay with the two things that you already know. So we already know this hypotenuse and this. So let us actually just keep using those and just circle our adjacent. So here's our three things. Two things I know, one thing I'm trying to find. It's not that you can't use your other numbers, but if you do, make sure you're keeping them to at least like 4 decimal places or so to make it more accurate. Otherwise, your answer will probably be off by a little bit. Okay. So here I circled adjacent and hypotenuse. Adjacent and hypotenuse is cos. So cos of A is going to be my adjacent over my hypotenuse. Substituting in, cos of A equals my adjacent, which is B, I don't know what, divided by my hypotenuse, which is 8.7. Basically looks exactly like our sine one, except with cos. So turning that into a proportion, I will divide by the 1 and multiply these two together. So B will be 8.7 times cos of, A, which I forgot to put in, 56. 56, cos of 56. Oh, sorry guys. So 8.7 times cos of 56. And I end up getting 4.864, or rounded to the nearest decimal place, 4.9, and my units are, here we go, centimeters. So B is 4.9 centimeters. Lastly, I need to find my final angle up here. Okay, so erasing this, erasing that, this here. So finding my last angle. Now I could use an inverse function, or I could use the fact that I know this angle is 90 and this angle is 56 and figuring out my third angle from my other two angles. Okay, so when I do that, I am using something called SMAT 180. And what SMAT 180 is the sum of the measures of the interior angles of a triangle is 180 degrees. So SMAT. Sum of the measures of the interior angles of a triangle is 180 degrees. So in our triangle toolkit, we have Pythagoras, the Pythagorean Theorem, we have SOHCAHTOA, and we have SMAT 180. And we use SMAT 180 if we circle 3 angles. So 2 angles I know, 1 angle that I don't. I can use SMAT 180. 3 sides, Pythagoras, 1 angle, and 2 sides, SOHCAHTOA. So we can use SMAT 180 here. So I know that the sum of the measures of the interior angles of a triangle is 180 degrees. So that means 56 plus 90 plus my angle B is going to be 180 degrees. So 56 plus 90, we get 146 plus B equals 180. Okay, so trying to get B alone, so we will need to get rid of that 146. This is like plus 146, so minus 146, minus 146. She gone. And I have angle B equals 180 minus 146, which is 34 degrees. And that's it. So I figured out that B is 34 degrees, side A 7.2 centimeters, side B is 4.9 centimeters, and my triangle is solved. I know every angle and I know what every side is. Okay, now for word problems, remember you should draw a picture and answer each question with a sentence, but we're not going to do that for this first one because it's not needed. So in right triangle ABC, the ratio of the side opposite angle A to the hypotenuse is 4/9, and what is the approximate size of angle A? Okay, so I want to know an angle. I want to know how big angle A is. Now this triangle ABC just means I have a triangle with vertexes labeled ABC, and the ratio of the side opposite angle A to the hypotenuse is 4/9. So this is where our important information is. So they're giving us this ratio, and they're saying that it's the side opposite angle A to the hypotenuse. And I'm trying to find an angle. Well, if I know the side opposite and I know the hypotenuse, I know that I can use SOHCAHTOA to figure out what my angle actually is. And since I have opposite and hypotenuse, I will be using sine. So sine of my angle equals 4/9. And we just solve. So get rid of sine by inverse sine. So sine to the -1 gets rid of that. And we have A equals sine to the -1 of 4/9. Then just putting that into our calculators, we get 26.387, so on and so forth. And let's just do that to the nearest tenth of a degree. Okay, so cutting off there, take a peek over the wall. That 3 is going to have to round up to a 4. So 26.4, our units are degrees, is what A equals. Done. Last example. We want to determine the angle of elevation to the top of a 5-meter tall tree at a point 3 meters from the base of the tree. Okay, let's start drawing our picture. I know I have a tree. Here's a tree. Tree in the ground. And I want to determine the angle of elevation. So remember, angle of elevation is from a horizontal up. Okay, so trying to find this. Let's call that x. So I want to determine the angle of elevation. So I'm determining an angle. That's what I'm finding. The top of a 5-meter tall tree. Okay, so this is 5 meters tall. At a point 3 meters from the base of the tree. Okay, so this point right here where I'm measuring this angle is 3 meters from the base of the tree. All right, so now I have my triangle. We have to label it. Okay, so here's my angle. So this is my opposite side. Here is my adjacent side. And here is my hypotenuse. Now circle 2 things you know, 1 thing that you're looking for. I know this side, looking for my angle. And I have circled an opposite and adjacent and an angle. So I know I'm going to be using sine, cos, or tan. And since it's opposite and adjacent, I know I'm using tan. So tan of my angle is going to be opposite divided by adjacent, TOA, over A. Now substitute in. So tan of my angle equals opposite, which is 5 meters, divided by adjacent, which is 3 meters. So meters, great, cancels out. And getting rid of that tan now. So solving for x, get rid of tan by tan to the -1. She gone. And x equals tan to the -1 of 5/3. Now, putting that into our calculator, we get 59.0362, so on and so forth. So the angle of elevation is 59 degrees. And that's it. Sorry for the kind of long notes there. You can start on your assignment.